In this video, we are going to continue about extremum of functions of two variables. The first example is a factory produces X mentioned and Y we mentioned every month. The selling price for mentioned is P1X and for we mentioned is P2Y. The total monthly cost for producing X mentioned and Y we mentioned is given by C of XY. Find the total monthly revenue and total monthly profit. The total monthly revenue is quantity multiplied by its price. Because there are two items, so the revenue function equals to X multiplied by P1X plus Y multiplied by P2Y. Then substitute the given price function and simplify. For the total monthly profit, it equals to revenue minus cost function. Substitute the function, then simplify. Question 1b is find the quantity for each type of shirt that required to produce when the profit is maximized. Hence, find the maximum profit. The quantity for each type of shirt when the profit is maximized means to find the values of X and Y when the first order partial derivative are both equals to 0. So, by using the profit function from A, we had to find the partial derivative with respect to X and the partial derivative with respect to Y. Now, let both pi sub X and pi sub Y equals to 0. We will get two equations in terms of X and Y. Use substitution method to solve for the value of X and Y. Before we find the maximum profit, we had to prove that maximum profit exists by using second order partial derivative test. So, find the second order pi sub double X, pi sub double Y, and pi sub XY. Substitute all this into the discriminant formula. Since the discriminant is greater than 0, and pi sub double X is less than 0, so maximum profit exists. Now we can find the maximum profit by substitute the quantity into the profit function. Then make a conclusion. The price for mentioned and the price for women's shirt can be obtained by substitute the values of X and Y into the price function respectively. Then make a conclusion. Example 2 is, a firm has two separate manufacturing plants producing the same item. Let X and Y be the amount produced in plant A and plant B respectively, with respective cost functions given by C1X and C2Y. The selling price for each of the item is 15 ringgit. Find the profit function. The selling price for each item means that P1X and P2Y are both equals to 15. Before we find the profit function, we must have revenue function and cost function first. So, the revenue function is the multiplication of quantity and its price for both items. The cost function is the sum of C1X and C2Y. Then find the profit function where it equals to revenue function minus cost function. Question 2b is find the number of units to produce at each plant in order to maximize the total profit. This means to find the values of X and Y when the first order partial derivative are both equals to 0. So, find the first order partial derivative with respect to X and with respect to Y. Then let both equals to 0. And we will directly get the values of X and Y. Use discriminant to prove that the maximum profit exists. So, find second order partial derivative pi sub double X, pi sub double Y, and pi sub XY, which is equals to 0 because there is no Y in pi sub X. Substitute all this into the discriminant formula. Since the discriminant is greater than 0 and the pi sub double x is less than 0, so maximum profit exists. Then make a conclusion. To find the maximum profit, just substitute the quantities into the profit function. Then make the conclusion. Example 3 is the yearly profit in 1,000 ringgit of a clock manufacturer is given by pi xy, where x is the number of type P clock in thousands and y is the number of type Q clock in thousands. Calculate the quantities of each type of clock manufactured per year to ensure maximum profit. As usual, we will find the first order partial derivative with respect to x and with respect to y. Let both equals to 0, then we will get two equations in terms of x and y. Solve by using elimination method where we add both equations to eliminate 8x. Then, substitute y values into equation 1. And don't forget to prove by using the second order partial derivative test. Then, make a conclusion. The quantities must be multiplied by 1,000 because the quantity is defined in thousands. To find the maximum profit, we substitute the values of x and y into the profit function. Then make a conclusion. Since the profit is also in thousands, so we must multiply it by 1,000.